everyone, welcome to Math World. Alright, today I'm going to talk about completing the square and writing your quadratic function in vertex form. So first we have to understand a concept about a perfect square trinomial. So this trinomial here, x squared plus 10x plus 25, is a perfect square trinomial because it follows the rule where b divided by 2 squared equals c. Now that means b, the middle term, 10, divided by 2, which is 5, and then squared, that makes 25, is the c term, 25. So you can see that c is equal to half of b squared. Now, if that happens, that means this is a perfect square trinomial. And because it's a perfect square trinomial, it can be factored to show us the two binomials x plus 5 times x plus 5. These are the binomials that, if we were to multiply, would get this original trinomial. X times x makes x squared. X times 5 makes 5x. 5 times x makes 5x. Add them together, you get 10x. And of course, 5 times 5 makes 25. So this trinomial and these two binomials are equivalent. And that's because it's a perfect square trinomial. And once you have these two binomials that are exactly the same, you can rewrite it as x plus 5 squared. So this is an important concept that we have to understand, that this trinomial is equivalent to this factored form, x plus 5 squared. Alright, so if we understand that, we can make any trinomial a perfect square trinomial by completing the square. That's the name of the verb we're going to do. So for example, let's say we had something like x squared plus 10x plus 17. And we can just set it equal to 0, that's fine. So this trinomial is not a perfect square because it doesn't follow the rule of b divided by 2 squared equals c. Half of 10 squared is not equal to 17. So could we do something to make this trinomial perfect square? And yes, we can. We can change this trinomial by using an equality statement such as add 8 to both sides. Now by doing that, by using add 8 to both sides, we've now essentially made this trinomial that was x squared plus 10x plus 17 now be x squared plus 10x plus 25. Now it is equal to 8 because we have to keep the equation balanced. But now we have this perfect square trinomial, just like we did over here, that we know can be rewritten as factored form x plus 5 squared. So this little adding of the 8 here that I did, when I added 8 to both sides, that is the completing of the square. Taking a non-perfect square trinomial and turning it into a perfect square trinomial that can be factored. And it is still equal to 8 because we haven't got rid of that. Alright, so next let's talk about vertex form. So vertex form, it is, so if we have standard form over here, standard form is ax squared plus bx plus c. Well, vertex form is a times x minus h squared plus k. So there's vertex form. And what vertex form tells us is it tells us the vertex, where h is the x value of our vertex and k is the y value of our vertex. That's why they call it vertex form, because it tells you the vertex. Alright, so looking back over here at our trinomial x squared plus 10x plus 17, that was in standard form. We completed the square by adding 8 to both sides. It's now a perfect square trinomial. We're then able to rewrite it in its factored form, x plus 5 squared. And it's not almost looking like this vertex form, but not quite. This 8 over here, though, we can now actually inverse operate to get rid of that 8 on the right side of the equation, and to keep it balanced, subtract 8 from both sides. And what that's going to do for us is it's going to put it into vertex form. So now we have x plus 5 squared minus 8. And this is vertex form. We don't really have an a value, or an a value is 1 if you want to think of it as a 1 being multiplied in front, which just like our original standard form, the a value was 1. Now, this 5 here, though, is actually kind of like this. It's the h right here inside of our vertex form, but because our formula is minus h, the only value here that would make this positive would be a negative 5. You can think of this as subtracting a negative 5. In this case, h is equal to negative 5. Now, what that means is that our vertex has an x value of negative 5. Our vertex will be parentheses negative 5, and the k out here, k is this negative 8. In this case, k is, from our formula, equal to negative 8, which means that the y value of our vertex is negative 8. So we took this trinomial, we completed the square so that we could write it in a factored form and then subtract the value from the right side of the equation to turn it into vertex form. We've transformed this standard form equation into a vertex form equation, and I kind of ran out of room here, but it's now equal to 0 because I subtracted the 8 from the right side of the equation, and there is vertex form. Alright, let's try one more just to see it a little bit faster. I'm just going to take kind of a random one. Let's say we have x squared minus 18x plus, I'm just making numbers up here, plus 11 equals 15. Alright, so that is a standard form equation. I have no idea what it looks like. I just made it up. But what I do know is I can turn this into a perfect square trinomial using that trick that I need the c value. The c value must be equal to b cut in half and squared. So in this case, the b value is 18. So 18 divided by 2 is 9. And squared, 9 times 9 is 81. So I need my c value to be 81, but it's only 11. Alright, so how can I complete the square? Well, I would have to add 70 to that, because I knew that 70 plus 11 would make 81. If you add to one side though, you got to add to the other side of the equation to keep it balanced. But I've now completed the square. So completing the square is pretty simple once you understand what that c value must be. I am left with an 85 over here now on the right side of the equation. Alright, so this is a perfect square trinomial, and since it is a perfect square, I can write it in its factored form. Let's see, I need it to be half of the b value. Half of the b value, half of negative 18 is negative 9. I'm writing it in this factored form because I know that x times x is x squared, negative 9 times x is negative 9, negative 9 times x is negative 9, and when you add them you get negative 18x, and when I multiply negative 9 and negative 9 I get 81. So these two binomials multiply to make this trinomial. I still have 85 over here on the right side of the equation, and this can be rewritten as x minus 9 squared because they are the same number being multiplied by itself. And now the last thing I'll do is turn it into vertex form by taking this 85 and sending it back to its friend over here, sending it back to the other side of the equation by subtracting it from both sides. So that gives me x minus 9 squared minus 85 is all equal to 0. And we know we want to solve equations when they're equal to 0. But right now we're writing it in vertex form. It is, so the vertex of this equation, if I were to graph it, I know the vertex would have, it's going to be the opposite value of what I see inside the parentheses because of that minus h. In this case, the minus h is 9. So, h is 9. So the vertex would have an x value of 9. And let's see, over here is subtracting 85, which means the k value is negative 85, and that is the y value of my vertex. So negative 85. So kind of a weird vertex, but like I said, I just made this up. But I did it because I know how to complete the square and write it in vertex form to find the vertex. Well, that's it, and I hope to see everyone in class soon. Take care. What's up, class? It's Mr. Bigsby with a hat, and I've got a challenge question for you. Can you take this trinomial in standard form of x squared minus 22x plus 1 equals 0, and I want you to rewrite this in vertex form. So complete the square, rewrite in vertex form, and put the vertex in the comments. Alright, later. Now for a word from our sponsor, Paper Cut Games. This week's game is King Domino. This is a relatively new game, and it did win the Spiel des Jahres, which is Game of the Year. So it's a pretty popular game, and it's a really good game because of how simple it is. It plays 4 players, but it works with 2 as well. And basically, it's like a world-building domino game. So the box just comes with a bunch of these little like domino pieces, but instead of like regular dominoes with just numbers on them, they have little like water or land on them, and you want to try to build, you want to connect them to make little cities. So you'll connect your water with your water, you'll connect the land with the land, and the cave with the cave, and whoever builds the best city wins the game. So it's a fun little world building game, but what's interesting about it is it's a drafting as well. So when the game starts, you'll lay out 4 of these tiles, and you'll take turns picking them to add them to your city. So maybe you want to have some caves, so you take the cave tile and add it to your city. And maybe somebody else wants to add water to their city, so they take the water tile. And there's, I think it's maybe 6 rounds or something like that. And at the end of the city, at the end of the round, everyone looks at how they made their town, and hopefully you connected water to water and the lands to the lands and caves to caves, and you can accumulate points, and whoever has the most points for having the best city wins the game. So it's real simple, and it's fun because you're trying to build your own city while looking at other people's cities and like, oh, I don't want you to have that. And that is King Domino. You can see it's on Amazon for 18 bucks. It's quick, it takes about 10 minutes to play, and it's really fun. Give it a try. King Domino. I'm Mr. Bigsby, and I approve this message.